I've talked quite a bit about ways to speed up Python over the course of this channel. So I've talked about Cython, I've talked about Number, I've talked about MyPyC. All these have something in common in that they're all tools to help normal Python code be faster. What we're talking about today, which is PyPy, takes a different approach entirely and is instead a completely different implementation of Python. So for those that don't know, the default implementation of Python is CPython. If you don't know about the different implementations, that's probably the one you're using. And there are other different implementations as well, like IronPython and Jython, or is it JPython? I can never remember. But PyPy is one of those, and it is designed to be faster than normal Python. It does this in two ways. So the first is by using just-in-time compilation. So as you have interpreted and compiled languages, Python is already somewhere in the middle. So Python compiles its code into bytecode, but then interprets that at runtime. Just-in-time compilation is kind of a different approach to that. So it identifies the most frequently used parts of the code and compiles them in real time, and then swaps the implementations out. So you instead run the compiled implementation rather than the bytecode implementation. In PyPy's case, it only compiles the most frequently used parts of the code because the actual compilation itself has a little bit of an overhead. So if you were to compile something you're only going to use once, that would actually overall be slower because you'd have the overhead of compilation, which would more than negate the benefits of having it run faster to begin with. The second thing that PyPy employs is a different way of doing garbage collection. So CPython uses both ref counting and cyclic garbage collection, whereas PyPy only uses the latter. And whereas CPython kind of does all its garbage collection in one go, PyPy kind of does it in micro jobs, which means that not only is PyPy spending less time actually doing memory management, but it also spends less time recovering from memory management with its micro jobs, and everything is a bit smoother. Another thing to keep in mind is that the PyPy interpreter is written on top of something called RPython. It's not RubyPython like I thought it was, and it's also not RustPython either. It stands for Reduced Python, and it is a subset of Python specifically designed to build interpreters on top of. And code that runs through RPython needs to be sufficiently statically typed, or at the very least type stable. The extent of this, I'm not 100% sure. I did some testing and it did seem to be able to do some coercion between strings and ints, for example. So the amount of type stability you need, I don't know. But generally speaking, anything that compiles, or not compiles, but runs through MyPyStrict just fine, will be perfectly fine in MyPy, provided it doesn't use C libraries at any point, which PyPy can't use. It's not compatible with. That's the general gist of it anyway. There are other resources if you want kind of a more detailed explanation. I want to focus more on the actual real world speed benefits in this video, but the PyPy documentation is a good place to go, and there's also a good Read Python or Real Python article that kind of explains it in a little more detail than I have just then. And now we're going to talk about the actual practical speed benefits and just how much faster PyPy is than CPython. So to do that, I've got three examples here. So I've got the classic bubble sort example. It's the exact same one that I had in the Cython video. I also have the exact same factorial implementation as I did in the Cython video. And I've put this here to show that PyPy can actually handle some of Python's more magic capabilities, like extremely large numbers, which is not something that Cython can do. And I also have this prime calculation thing in here as well. And then I also have this benchmark that will tell us how fast each thing is running. So one thing to note for the sort, I'm actually loading it from a file, which is a little bit jank, but it does ensure that both CPython and PyPy are getting the exact same data, so there's no unfair advantages through random generation. But the rest are, pretty simple. You just read the files to import the function, and then just call the function, and then call it. In the case of the sort, we're calling it 1,000 times. In the case of the prime, we're calling it 100 times, and the factorial, calling it 500 times. So if we load this, you can see I'm using pyenv to swap between the two environments. Installation instructions are provided on the PyPy documentation if you're not using PyEnv. And we're just going to do pybench.py. And this will calculate how long it takes, or this will run through each operation the set number of times, and it will spit out the amount of time it took to do all of it. And then we can compare them by running them against PyPy later on. So the sorting took 12.8 seconds. So that's sorting. I actually don't remember how many numbers that is. So it's 1,000 numbers between 1 and 100. And it's doing that 1,000 times. So that took 12 seconds. To get all the primes up to and including 10,100 times took 15.8 seconds. And the factorial, I think, is a little bit faster. I might be wrong. Seeming like I am. I did intentionally try to make them 18.3 seconds. I did intentionally try to make them not super long. So nothing that would take hours. Because otherwise that would be a bit awkward. So if we then swap out, whoops, I'm in the wrong thing. So if we then swap out our local environment with Carbra Pi, oh god, I've got so many PyPy, which is the one with PyPy installed, and I can prove that. So we're using 7.3.11 in the back end. We just Control D out of it. And then run the exact same thing again. We can see that the sorting and the primes specifically are a lot faster. So we've got 1.7 seconds and 0.9 seconds. You will notice that the factorial is 7.5 seconds, which is still a lot quicker than it was in CPython, just not as much quicker as it was before. One thing I did forget to mention that I'll talk about now, you'll see that in CPython we're using version 3.11.1, and in PyPy we're using version 3.9.16. This is the latest version of Python that PyPy supports. And I was originally going to compare it against CPython 3.9, but I thought, well, that's not really fair because 3.11 is quite a bit faster than 3.9. So I thought I'd give CPython the best advantage I could. But you can see the differences. I mean, we're looking at, what, like 10 odd times faster for the sorting. Something close to like 16 or 17 times faster for the primes, and the factorial it's about twice as fast, a little beyond. The reason why the factorial one isn't as much faster as the other two is because the numbers of the factorial are, a lot higher than something C can normally do, which is where Python's magic kind of comes into it. And the moment Python's magic starts coming in, PyPy's optimizations start to become less and less effective. So they can still support, all these huge numbers. It's just that the speed ups won't be as pronounced if you are relying on it. And I can quickly prove that it does actually work. So if I should be able to just import fact from here and then do fact.factorial 10,000. I can see that the value error exceeds the limit 4300 for integer string conversion. So although we can't actually display the number, you can see that the number is larger than 4,300 digits long, which I think is probably proof enough. Python would just set this as 0 if it were to do that. So yeah, that's PyPy in a nutshell. You don't even need to type hint your code, you just need to make it type stable. So it's not even as arduous as MyPyC to do, and it's actually faster than MyPyC as well, which is kind of cool. I think the average speed up is somewhere between 5 and 15 times. The fastest I've seen it do is 20 times faster. Though according to PyPy, there are things that are slower, like Sphinx documentation building appears to be slower in PyPy than it is in CPython. So your mileage will vary with it, but it's definitely worth a shot if you're looking to run your Python programs a little bit faster. Of course, if you found the video helpful at any point, then consider liking to let me know, and maybe subscribe if you want to see more videos like this. If you have any questions or ideas on what videos I can do in the future, then make sure to leave them in the comments below. I read every single one, so your feedback is greatly appreciated. If you want to support this channel monetarily, you can do so in one of two ways. The first of which by becoming a member, the second which by becoming a patron. £1 a month on either, and you can be in this screen like these people. And I will see you in the next video. We do something really cool. I'll see you for that.